lab involving, in order to determine the formula mass, actually the formula for magnesium oxide. What is that formula? So the title is going to be, what is the formula of magnesium oxide? Obviously, this is not a controlled experiment. We're not looking to see what happens to the independent variable, to the dependent variable as you change the independent variable. So you need to keep that in mind. This is more of an investigative type, CSI type experiment. Purpose, as always, at least 4 sentences. Should be a nice chunky paragraph. Describe what you want to find out. Describe how you're going to find it out. At least 4 sentences. Hypothesis, it's not a controlled experiment, so no if or then statement. Turn the question into a statement, then answer it. The formula of magnesium oxide is, well, remember that hypothesis should be an educated guess. In your case, you are highly educated. You should be able to know what is the formula of magnesium oxide. Background, easy. Easy peasy lemon squeezy. 3 uses for magnesium oxide. That's it. Just 3 uses for magnesium oxide. Cite your source. Materials, you're going to be using a crucible, magnesium strip, tongs, Bunsen burner, ring stand, balance scale, clay triangle. Procedure, I'm not going to tell you, but let me tell you a story. Once upon a time, there was a certain good-looking and charming chemistry teacher who wanted to find out the formula of a copper oxide solution. Was it copper 1 oxide, or was it copper 2 oxide? He measured the mass of a crucible, and then he recorded the mass. There's a crucible, there's a balance scale. He then placed a little bit of copper into the crucible and massed it. He recorded the mass. He then placed the crucible in the clay triangle and heated the crucible. He adjusted the flame so that the inner blue flame is hitting the bottom of the crucible. So remember, if you've got a good flame going, then you should have an outer blue cone and an inner blue cone. The bottom of the crucible should be being hit by the inner blue cone. That will make the crucible as hot as possible. The copper started glowing and then turning black. He turned off the burner and let it cool down. Ceramics absorb water naturally. This is very important that you remember this. Ceramics normally absorb water. So if you have a cool piece of ceramics, there's going to be a certain amount of water. Is it enough to measure? Just barely. Okay? So when you heat up a crucible, that water leaves. That water is driven away. So a cool crucible will have water, a hot crucible will not. So when we measure the crucible initially, it was cool. So it's going to have, some of that mass is going to be measured with moisture. So some of that mass is going to be water. If we mass it while it's hot, it will not have the moisture, therefore it's going to weigh less than it should. Remember, the initial mass that I had included water, so when I mass it again, it should also include the water. So what does that mean? That means that he had to wait for the crucible to cool down in order to get back the moisture. The general rule of thumb is, if you can hold it comfortably in the palm of your hand, it is now cool enough to measure on the balance scale. So the crucible with the black copper blank oxide was then measured on the balance scale and the mass recorded. Precautions. The crucible will be very hot. Hot ceramics looks the same as cold ceramics. You must allow it to cool down. Burning magnesium will emit a very bright light, so bright that it could actually damage your retina. You must not look directly into the light. You must look at it indirectly, believe me. The light will be so intense that even through the opaque ceramic, you will see light going through. Normal Bunsen burner precautions: tie your hair back, no loose clothing, wear appropriate clothing. Alright, so this is the data that this handsome chemistry teacher got. The mass of the crucible was just 31.320. The mass of the crucible and the copper before it was heated was 32.210. The copper was heated, it reacted with the oxygen, forming copper 2 or copper 1 oxide, and its mass is now 32.418. He now had enough data to solve the mystery. How? Well, he was able to find the mass of the copper by simply subtracting the crucible and copper from the crucible and copper from the crucible. 31.320, that's just the crucible. Crucible plus copper is 32.210. That gave us a mass of 0.890 grams. To find the mass of oxygen, he took the mass of the crucible and the copper and the oxygen, 32.418, and he subtracted it from the mass of the crucible and just copper. So the difference there would be the oxygen. That mass was 0.208 grams. Okay, this is a simple empirical formula type question. You know the identity of both elements. You now know how much of each element you have. Divide by the formula mass to get moles. Divide by the smallest mole, which is oxygen. You get a ratio of 1 to 1.1. 1.1 can be easily rounded down to 1. So you have 1 Cu and 1 oxygen. I want you to find percentage error. I'll let you know what the percentage error of magnesium oxide, well, you should already know the identity of the actual formula for magnesium oxide, since you know its charges. People back 150 years ago didn't know anything about charges, so this was all brand new to them. They were figuring out charges by doing a bunch of these experiments. So, the real formula is CuO, with the formula mass of 79.5. The experimental formula is CuO. That's what the handsome chemistry teacher got. CuO. And its formula mass is 79.5. So true minus observed divided by true times 100. Data analysis. Make sure you summarize what you found out, and you describe the sources of error. You must find sources of error. Conclusions. 6 to 8 sentences. Make this huge. Describe what you found out. Describe how you found it out. State whether your hypothesis was right or wrong. Suggestions. No reboot. What is the next logical step now that you've conducted this experiment? Don't revisit the experiment. Do not make suggestions for how you can improve this experiment. Take the experiment to the next level. And what I learned, demonstrate that you can use your gray matter, use brain matter there. Folks, I want some good thinking.